Alright, so in this video, we're going to talk about what's the minimum amount of information necessary in order to identify a linear function. Now, once again, our intuition about this sort of thing comes from geometry. So, let's take a moment and ask ourselves, if I took a plane and I drew a dot in the middle of the plane, is that enough to tell me, is knowing that this line passes through that dot enough to tell me which line that is? If we think about it for a second, it doesn't, right? Because there's all sorts of lines I could draw. Let me make my dot a little bigger there. I could draw through that point. I could have a line coming up. I could have a line crossing down here. I could have a line crossing down here. There's just all sorts of ways I could draw lines that pass through that point, right? So just knowing a point is not enough to identify which line I'm talking about. Now, let's say instead of a point, all I told you was a direction. Let's say you're going to be traveling northeast. Is that enough information to tell you what your line is? Well, I could start from here and go northeast, or I could start from here and go northeast. I could start from here and go northeast, right? There's just all sorts of different paths I could take. And so just being told a direction is not enough to identify a specific linear function. And so what I have here graphically are some examples of that. So here in this first graph, I have lines of slope 1/2, but my y-intercept is changing. So all of the lines, all of the versions of this line that's been shown here, they all have the same slope. But if you can change the intercept, that changes the line even if they have the same slope. On the other hand, if I want to look at lines that pass through the point, say 2, 3, if I'm just given a point, if I change the slope here, then that's going to change the line itself as well, right? We can see as the slope changes, we're getting different lines. So there's infinitely many lines that pass through the same point, infinitely many lines that have the same slope. So what do you need in order to be able to actually pin down a specific linear function? So let's go back to our plane here and say, hey, what about a point and a direction? So if you know where you're starting and you know what direction you're going to be headed to, then sure, this can be extended out to be a line, and there's only one line that it could be. So a point plus a slope is enough to identify a line. So let's do an example of this. How about a linear function with slope, let's say -2, passing through 3, 4. Alright, how's that? Alright, so let's recall to the previous video where we had the point slope form, and note that the linear function which satisfies both passing through 3, 4 and having slope 2 is the linear function 2 x minus 3 plus 4, right? What we have is that this 2 goes here, this 3 goes there, and that 4 goes there, right? Ever work this out, then that gives me y equals minus 2x plus 6 plus 4, which we can simplify to minus 2x plus 10. So let's go back to our trusty Desmos here. Blah, 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 blah. Let's go ahead and plot the point that we wanted. 3, 4. And then let's plot our line, y equals minus 2x plus 10. And boom, that's a line passing through our point with slope -2. And like I mentioned before, you can go ahead and, if you just wanted to leave it in that form, there's no reason you couldn't. It should graph the same line. All right, beautiful. So a point and a slope is enough to identify a specific line. What about, let's say, no, let's keep this color. What about, let's say, 2 points? If you have a point here and a point here, just think about, just take out a piece of paper and draw any 2 points on it. You can put a ruler next to those points and draw a line, right? I'm going to try mine. That's good enough. And not only could you draw a line, there is really only one line you could draw that would pass through both points. So it seems to me that 2 points out to be enough to identify a specific line. Now, finding the linear function that corresponds to this line is going to be a bit more work because we're not given any sort of slope, but we can identify the slope based on the information that we have. So why don't we go ahead and give these points some values. Let's say this is 1, 3, and this is 4, 4. And let's see if we can't figure out what this linear function is. Now, when I look at this, I notice that my x values go from 1 to 4, so that's a delta x, or a change of 3, right? In said time, my y values go from 3 to 4, so that's a delta y value change of 1. So the slope for this function is m, which is delta y over delta x, is 1/3, right? You can more formally write it out as 4 minus 3 over 4 minus 1. That's where 1 and 3 come from, right? If you want. But we worked it out up here already. So 1/3 is our slope. Now we have a slope in addition to our 2 points, right? And now we've sort of gone back to this situation here, right? If I take my slope and I take any point, that should give me a linear function. So I could express that as either 1/3 x minus 1 plus 3, right? That's using this point here, or I could use this point here to write y equals 1/3 x minus 4 plus 4. And the thing to note is that these are the same linear function. It doesn't matter which one you pick. I could have picked some other point even that lies on this line, but figuring that out is too much work when we already have these 2 points. And to sort of just verify that briefly, this is 1/3 x minus 1/3 plus 3, which gives me 1/3 x plus 8/3. On the right here, y is equal to 1/3 x minus 4/3 plus 4, which also simplifies to 1/3 x plus 8/3. So, to verify that these are all in fact describing the same line, let's go ahead and first plot our 2 points. Let's throw in 1, 3. Let's throw on 4, 4. Alright, so line number 1, we have 1/3 x minus 3 plus 1. Oops, my mistake. This is a 3, this is a 1. Nope, I had that backwards. That's a 1, that's a 3, that's a 1, that's a 3. There you go. And yes, in fact, passes through, right? Line number 2, y equals 1/3 x minus 4 plus 4. That's the same line, right? If I go back and forth between them, they're the same. And the last version of this was 1/3 x plus 8/3. Well, once again, that's the same line, right? All right. So to summarize, all the information you need to define a linear function is either a point and a slope or 2 points. If you have a point and a slope, then your strategy to find your line is to use the point slope form, which is one possible strategy. The other way you could go is to, if you have 2 points, is you use the 2 points to identify the slope by comparing the change in the y values to the change in the x values, and then once you have that slope, we're once again in the first situation. All right, thank you very much. If you have any questions, please let me know. See you in the next video.